Okay, we're in the example questions. And again, the point of this is that you really should pay attention to what I'm doing at the whiteboard and try to make sense out of it. And of course, it's based on the lecture material that I presented to you. Hopefully, as we go through examples, the lecture material will become more clear to you. The intent of this, though, is to get you to work problems on your own, not to watch me and say, oh, gee whiz, you can do that. We're not looking for me to do it. We're looking for you to do it. And you need to learn the material that we're presenting to you, all right? So some of this stuff is going to be review what you learn in Math 100. It may look a little different, but it's really essentially the same thing, except we do add on to it, of course. We are moving into a pre-calculus course. And the bottom line over here is that, my lectures should be listened to. And if you have questions, you want to get those questions resolved by coming during office hours. And we can do a one-on-one during office hours. And I'll be more than happy to help you if you need help. All right. The other thing I want to point out in the side over here, there's little side videos. A lot of students, what they do is say the lectures are too long. They can't go back and watch them. Well, if you're confused, you can watch these little side lectures. Of course, the side lectures are going to look a little bit different than the lecture, but I can't say substantially different. So I'm going to switch to the whiteboard now, and I'm going to start doing problems. All right, I'm on the whiteboard, and or actually it's a blackboard today. And I'm going to do one problem at a time. And as I do these problems over here, certainly I'm trying to encourage you to pay attention, but you should still have a piece of paper and pencil in front of you. You should make some attempt to write down or jot down notes as we're going through these problems here. So I'm going to look at the first one here. And this is number one. It says, given the following graph, I do see the graph. It says figure 3 on page 49. I'm looking at it. It says it's a relationship between a set A, and the set A is between -1 and 2. So what I'm going to do is I'm just going to outline, what the set A is. It's really the X values in the problem. And this is the X-axis over here. This is the X-axis. So this relationship starts at -1. I'm seeing it. And it stops at 2. And it includes those points over there. Now I'm going to write those points down for you. And this point over here is 2. This is a point. And I'm kind of ballparking it. It looks like 3. Right? What's this point over here? And again, I'm ballparking because I'm looking at a picture. To me, it looks like -1, 6. There's one other point I want to put down, and it's this point over here. And why is that? That to me looks like it's the minimal point on this particular graph. And what is that point over there? Well, I'm looking at it. I'm going to say 1, 2. Right? Now, granted, you can draw the picture if you want, trace over it. What does it look like? This is what the relationship looks like to me. It's visual. All right, let's see what the question is, though. And again, we'll go through the questions one at a time. The question is as follows, right? What do they want to know? They're saying this over here. Given the following graph, is the relationship between the set A and the set B. Now, they're saying set B. Set B is all the real numbers. It's all the real numbers. They're wondering, is the relationship functional? Well, it really goes back to what you did in Math 100. And certainly, you could reread those definitions again, but a lot of students have trouble with it. So what I'm going to do to know if it's functional, I'm going to look at the domain of it. I'll write this down for you. The domain of this particular problem is from -1 to 2. And the range of this particular problem, again, I want to make sure you're looking at it. We're looking at this thing over, it's the green portion of the curve. What's returning for the y's? And certainly the range is contained in that real number set. And what does it look like? Well, the least it could be, it looks like the least it could be is 2, and then it streams up all the way up to 6. So I'm going to say it looks like it's starting at 2 and it's going up to 6. All right, that's the range of it. Now, what was your question again? Again, determine if the relationship is functional. Well, I'm going to be honest with you. A lot of people read that definition of what functionality means and have a tough time with it. So we have a simpler way of approaching it. And the simpler way of approaching it is called the vertical line test. Vertical line test. And basically, it's really simple. It says, basically draw a vertical line. Can you find any section of that curve where the vertical line passes it twice? And the answers are resounding no. So if you can't find a line, a vertical line that goes through it twice, we're going to say this relationship is functional. So I'm going to say I use the vertical line test, and my conclusion is it's functional. All right. Where they say determine it's functional, I did that. I used the vertical line test, and I did specify the range. I want to claim over here the answers are being provided to you. It says the relationship is functional and the range is 2 to 6. I got pretty good about that. Again, we used the vertical line test. All right, let's go to number 2 now. I'm going to go over here. And number 2 says, graph. And this is where some students say, oh, I don't think I could graph that. Of course you can. It's a Math 100 question. So I'm going to write this down for you. This is number 2 now. X squared, all right, minus 4x. This is an equation of a circle, something you learned in Math 100, plus y squared. I'm just rearranging it, plus 6y, and then equals minus 4. And what I'm going to do is complete the square now. How do you complete the square? I'm going to take half of that guy's coefficient, which is minus 2, and square it. And you're going to add that number to both sides. So it'll be plus 4 to both sides. All right, let's keep going. And what am I going to do now? Complete the square on this y squared guy. And what's that going to be? Half of the 6 is 3. When you square 3, you get 9. So what I'm going to do now is I'm going to add 9 to both sides. All right, what do we have now? Again, I can't say this enough times. We're hoping to have perfect squares. And certainly on the left side, we have perfect squares. That's x minus 2 squared plus y plus 3 squared equals, well, if I add those numbers together, you would get 9 or 3 squared. So this is the equation of a circle. And this is good. It's something I learned in Math 100. So the center is going to be the point 2 comma minus 3. And the radius is going to be 3. What do they want me to do? Graph it. Well, I'm going to graph a circle out. And again, I'm not saying I'm doing a great job of that. That's what my circle looks like. And I'm going to put down points on the circle. How many points? Well, in Math 100, they said put down 4 points. The way I'm going to do this is I'm going to put the center down first. The center is 2 minus 3. I'm going to put this point over here. Well, the x didn't change, so it's still 2. But, I'm at minus 3, and I went up 3, and this is the y value. That would be 0. If I do this point over here, the x didn't change. I'm just moving down. And where would I be? Well, minus 3 moved down 3 would be minus 6. Now let's move left and right. What's not changing there is the y. So what do you get over there? You're at 2, but you move right 3 units. That would bring me to 5. And this is exactly the technique your teachers taught you in Math 100. So over there, again, moving left, the y didn't change, but what changed? The x changed. So you're at 2, but you move left 3. That would bring me to minus 1. Very simple arithmetic problem. So let me write this down again for you. I'm going to write down domain. And what's the domain of that guy over there? Well, looking at it, it's the x values. Well, what do the x values go between? Minus 1 up to 5. That's the x values. What's the range of it? Well, the range of this thing over here, looking at it, it's the y values. What is it ranging between? Well, it starts at minus 6 and it goes up to 0. Now, someone says, I don't think that was their question. And I'm not saying it was their question. What was their question? Graph it. We did it. We graphed it. We might have put more information down than we need, but we graphed it. Then it says determine if y is a function of x. Here's the deal. What you're going to do is you're going to draw a vertical line. I'll put one down over here. And what I notice with the vertical line, I can find a vertical line that goes through it twice. So I'm going to say this is not functional. And what did I do? I used the vertical line test to determine that. What's the problem with the vertical line test? It requires an image, and that could take a lot of effort, all right? So again, if you read the key over here, it does say there's a better graph provided to you, and it says an equation of a circle, vertical line test, y is not a function of x, all right? Let's go to the next question, which is number 3. And number 3, I want to point out to you, it's a simple question, very similar to what you did in Math 100. In fact, I just copied this from my Math 100 notes. I'm going to write it down for you. The first thing, A, what they want me to do is they want me to do f of minus 1. How would I do that? I would recommend to parenthesize the variable and then plug in the value. And what's the value going to be? Minus 1. And yeah, you have to do that arithmetic. This gives me 1 plus 3 plus 1, and 1 plus 3 plus 1 is 5. I want to claim the answers are written over here. We'll look at that for each problem separately. Let's do B. What's B say? F. Well, I got to be honest with you. If I write the letter S down, it's going to look like the numeral 5. So I'm going to use the cursive S. What do? Parenthesize the variable. and then plug it in. Now, what am I plugging in now? The letter S. What do you get over here? S squared minus 3s plus 1. All right. Again, if you look at that, I see that right over there. Let's go to the next one, which is C. What does C say? F of 2x. What am I going to do over there? Parenthesize the variable and plug it in. What do you get there? 4x squared minus 6x plus 1. The reason we give you an answer key is we want you to look at it. And the reason to look at an answer key is that, sometimes you think you're right when in fact you're wrong. And it happens to me sometimes too. I misread a question. All right, let's keep going. The next one's going to be f of a plus b. All right, so I'm going to write that down for you. Push this over. F, this letter, we're on D now, right? So f of a plus b. Well, what am I going to do? Parenthesize the variable and then plug it in. Okay, some students have trouble with this, and really what they're having trouble with is, lower level algebra classes. So what I want to do is I want to go through it with you. I'm going to make sure you know that you need to square a plus b. Now, a lot of people write the wrong thing down and say, well, what's the big deal? It's a big deal. You don't want to write wrong answers down. There's no point writing a wrong answer down. That's what it means. Now, if you multiply this out, what do you get? A squared plus ab plus ab plus b squared. I'm using a distributive property multiplication. So I know what it is now. And I'll write this over here. F of a plus b. Well, the first term when I square it, I got a squared plus 2ab plus b squared. All right, that's just the first term. Let's do the next one. Whoops. I unfortunately touched the off button there. Sorry about that. I'm back. All right, now what am I going to do? The second term. And what is going to be second term is a product 3 and another factor a plus b. That would be minus 3a minus 3b. All right, then what? Plus 1. Now, I would look for something else to do, but there's nothing else I can do with that problem. Look at the key to make sure you're seeing that. I'm seeing a squared plus 2ab plus b squared minus 3a minus 3b plus 1. Let's do the last one. I'm getting a little bit better at this now. And you can even remember the function. Let me write this over here for you. E, what's E? F of A minus F of B over A minus B. Well, again, I'm getting a little better at this. And what I mean by that is I think I can do it. And what am I looking for? Well, F of A, what's that going to be? A squared minus 3A plus 1 minus F of B. I'll write that down for you. That's B squared minus 3b plus 1 over a minus b. Now, I'm going to look at the answer key and I'm saying, oh, gee, I didn't get their answer, so there must be something wrong. So I'm going to keep working. All right, I'm going to see if I ever get that answer. And I sort of remember it, but I'm going to write this down now. I'm going to write down a squared minus b squared minus 3a. Let's see, minus a minus 3b is plus 3b. And then 1 minus 1 is none. Well, you know what? That's still not their answer. So I'll keep going. What am I going to do? I'm going to try to factor the top. So a squared minus b squared is a plus b, a minus b, and then, minus 3 and minus 3b, I'm going to factor out minus 3. What do we get left off with? A minus b, all over a minus b. Well, what am I going to do? I'm going to factor the top now. And what factors out from those two terms? A minus b does. What are you left off with? A plus b from the first term and minus 3 from the second term, all over a minus b. Yeah, I know it's work. What happens over here? These cancel off, and you're left with something really simple in the end. What are you left off with? A plus b minus 3. And there's not much I can do about that. Again, I want to point out, I know for a lot of students, oh, that's too much work for me to do, but you want to do that work. Your obligation is to work, and we got that. All right. So I'm going to say, not too bad. I mean, the first page went pretty smoothly. Let me go to the next page. And the next page is just a nice picture of that circle. A machine did it. And we'll learn more about using machines later. But right now, we want to encourage you to use hand, right? I'm going to say this over and over again to you. If you can't do things by hand, like simple problems by hand, you're never going to get to the machine level. But most real world problems are done by machines. Let's go to the next page. And next page is going to be, I'm looking at this thing over here. We went through that one. Now we're on problem number 4. All right, let me put problem number 4 down for you. And I don't know, looking at it, it says, given this function over here, find the difference quotient. Well, you would need to know the difference quotient. And what's the difference quotient? F of x plus h minus f of x. This is a difference quotient over h. And this was covered in the lecture, and it's certainly written in your notes. So what do I have to do? Well, a couple of things. One thing I need to do, I need to write down f of x plus h. And what's that? Parenthesize the variable and plug it in. And yeah, some people say, oh, it's too much work. We want you to do the work. What does this give me? 3x plus 3h minus 2. And again, if you need to, on the side, write down x plus h times x plus h. But you should be getting better at this. This is something that really you've been doing for years now. X squared plus 2xh plus h squared. I'm going to keep writing it down. This is 3x plus 3h minus 2x squared minus 4xh minus 2h squared. Now what do we have to do? Well, I got to do that top. And someone says, what is the top? It's f of x plus h minus f of x. Well, I'm going to write that down for you. And what's that going to be? 3x plus 3h. We just did it, right? Minus 2x squared minus 4xh minus 2h squared. And what are we doing? We're subtracting away f of x. What's f of x? Well, 3x. So I'll subtract away 3x minus a minus 2x squared, which would be plus 2x squared. What do you get over there? Something pretty simple. You get 3h minus 4xh minus 2h squared. Now, I realize sometimes you can say, I'm much faster at this. You can be. We're not saying you should be slow at this. But what am I going to do over here? I'm going to write that down now. I just did the top. What do I get? 3h minus 4xh minus 2h squared all over h. And the bottom line, someone says, could you do that? And you can. If you were to divide through by h, what would you get? Well, 3h divided by h is 3. Minus 4xh divided by h is 4x. And minus 2h squared divided by h is minus 2h. Okay, let's go to the next one, number 5. Number 5 says find the domain. And again, this is something you did in Math 100. Now, the bottom domain is that we're looking for troubles. And I don't see the troubles that you see at this level. Again, there's going to be more troubles later on, but I see no divisions and I see no even roots. So what I'm going to say is all real numbers. And that's a fine answer in the box. You could also use what's called the blackboard R. It looks like this. How's it read? All real numbers. However, we like to write the interval down. What's the interval look like? It's all the numbers. And that's what it would look like, the whole interval. That answer's right over there. Again, we're looking for trouble for domain. Domain is an easy thing to do for the most part, unless there's troubles. Let's look at number 6. What's number 6? Find the domain. Well, again, I'm going to write down all real numbers. However, there are some troublesome numbers. And the troublesome numbers is when the bottom becomes 0. So I'm going to say except this. All right, well, let's solve with this one. X and X. I'm going to say, let's see, you get 3 and 2, right? Let's see, minus 3 plus 2. Let's just check it. I get x squared. 2 minus 3 is minus 1x, and you do get minus 6. So what are the troublesome numbers? 3, and the other troublesome number is going to be minus 2. So I would say all real numbers except x can't be 3 and x cannot be minus 2. You can use the blackboard R. And what would that look like? That would look like this. And that blackboard R is read as all real numbers. We'll check the answer later. That's a fine answer. Our goals are really write an interval down. And what's the interval going to be? Well, let's write down minus infinity up to minus 2, don't touch, union, minus 2 up to 3, don't touch, union 3 off to infinity. And our goal is intervals. We like to write intervals down. I see the intervals in the answer key. And make sure you can follow that. All right. It may take effort on your part. It's the effort that's going to pay off. All right. So we got 6. We can go to number 7 now. These are kind of straightforward problems. Let's see number 7. It's a domain question. And I'm looking at it and I want to see if I can do it. And the domain of this thing is, again, you could be snappy and say all real numbers. I'll write that down for you. That meet the condition. The condition is that x squared, this is an even root, by the way, minus 8x plus 12 has to be non-negative, which means it's greater than or equal to 0. Now, have we seen that before? We have, right? That's a quadratic inequality. That's the first thing we've done this semester, right? We solved inequalities. Let's see if we can solve it. And I'll put this over here, x and x. Again, if you can't do this, you probably shouldn't be in this section. You should probably go back to section that we did initially, which is the quadratic inequality. It was new, I know that, all right? So I'm gonna say, I don't know, 2 and 6, minus, minus. Let's see if that works. You get x squared. You do get minus 8x and you do get plus 12. Number line goes down. On the number line goes the zeros. What are the zeros? 2 and 6. I'm gonna claim, at least I hope I can claim, that if you study the prior material, that this is getting much easier for you now. What do? You take test points. And what's a good test point after 6? I would say 7. If you plug in 7, what would you get? Positive times a positive, which is clearly a positive number. So that would get shaded in. This gets shaded in. It's all positive here. All right. Let's take another test value. Let's take a test value between 2 and 4. I would say like 3 is a good number to choose. What would you get? Negative times a positive, which is a negative number, and negative numbers are not greater than 0. I can't have that. All right, let's go below 2. What's a good number below 2? I would say 0. And what would you get? A negative number times a negative number, which is a positive number, and positive numbers are certainly greater than 0. So that gets shaded in. What else gets shaded in? Is it ever equal to 0? Well, if you plug in 2, you get 0. And if you plug in 6, you get 0. So now I know the domain. All right, and I'm going to write the domain down for you as an interval. All right, let's write the interval down. What's the interval going to be? The interval is going to be from minus infinity up to 2. That's on the right. It's inclusive. Union, it starts up at 6 on the left, inclusive, and it goes off to infinity. All right, that answer's there. Let's go to number 8. Number 8 is a problem, and I'll tell you what the problem is. I'm looking at it. There is a division and there is a root. It's an odd root though. Odd roots have no restrictions. It's only the even roots. This index is 3, it's an odd number. Here's the deal though. Is there a number that makes a division by 0? And the question becomes really simple if you look at it. 2x minus 3 shouldn't be equal to 0 because it had division by 0. Can I solve that equation? Yes. Oops, sorry about that. X would equal 3 over 2. So what am I saying? It's all the real numbers. Except that troublesome number, which is 3 over 2. This could be written in Blackboard R, X not 3 over 2. There's nothing wrong with that. This is a good looking answer. This is a good looking answer. We want to write intervals down. What's it going to be? Minus infinity up to 3 halves, not touching it, union 3 halves off to infinity. You got to get used to intervals. It's something that can be done again and again from this course forward. All right, I did it again. Sorry about that. So let's go to the next one, which is number 9. Over here. Ooh, this is an interesting one. It says, write the circumference of a circle as a function of its area. Now there's footnotes over there, but I'll say for the most part, you don't have to read the footnotes, but they may help you. All right, let me write circumference of a circle down. Circumference of a circle is 2 pi r. That's a grade school formula that most students can remember from their grade school days. The area of a circle is going to be pi r squared. All right, no formulas are given to you in the notes, by the way, if you can't remember that. What does it say? It says write circumference as a function of the letter A. Well, you know what? I want to point out that circumference is written as a function of the letter R. I got troubles. What's my troubles going to be? I need to write as a function of A. So I need to find out what R is in this equation over here. Well, let me go through that with you. It's A over pi equals R squared. All right, I just divide both sides by pi. Pi is a number. I got trouble here, and certainly my trouble is, what's R? Well, R is the radius of a circle, and I hope you realize that R has got to be a positive number if it's a circle. So if you went back to mathematics, you would say R equals plus or minus, but since R is positive, what am I going to say? R is not plus or minus, it's just simply going to be the root of A over pi. Again, R cannot be negative. All right, that's done. So let's write this down. Circumference is a function of area. Let's write it down. Well, I'm looking at it. It's 2 pi r. What's r? It's the root of A over pi. By the way, I think it's a good answer, and you're done if you're done, but I gotta be honest with you, looking at it, it looks a little strange to me, and it doesn't match their answer anyway. So let's go through that. So I'm gonna write this over here, 2 pi times root A over root pi. Again, I'm going back to mathematics. Mathematics, they didn't like the radicands to be fractional, and they didn't like having radicals in the denominator, and they rationalized. It seems like work to you. What do you get over here? 2 pi square root pi a over pi. Now, what's nice about this guy over here? The pi's cancel off. And what are you left off with? Well, I'll write it down for you. You're left off with, let's see, 2 root pi a. That's the simplest possible answer you could write down. And that answer is right over there. All right, let's go to number 10. And number 10 is a question about, is the function even, odd, or neither? And let me remind you what an even function is. All right, I'm going to remind you. So let's take a look. So even, the test for even is, does f of x equal f of minus x? If it does, we're going to say it's even. Okay. Okay, next up, odd functions. Is f of x identical to minus f of minus x? And if it is, we're going to say it's odd. Now, if it doesn't meet those two conditions, I'm just going to say neither. So let's take a look at each one separately. And to do that, what I do for A, all I have to write down for A is, basically, I have to write down f of minus x. And I'm getting a little better at this. All right, we've done this before. And hopefully you're getting better by trying. So if you took minus x and squared it, you would just simply get x squared. If you took minus x and cubed it, you would get minus x cubed. This looks a little strange to me, so I'm going to multiply top and bottom by minus 1, and I would get minus x squared because I multiply top by minus 1. If you multiply the bottom by minus 1, you would get x cubed plus 1. Now the question is this. Is this the same thing as f of x? Well, I'm looking at it, and the answer is no. So I'm going to write that down. So f of x is not the same thing as f of minus x. So I'm going to say it's not even. All right. The next question is f of x the same thing as minus f of minus x? Well, let me write minus f of x down for you. Minus f of minus x would equal x squared over x cubed plus 1. Well, I'm looking at it, and it's not the same thing, so it's not odd. So what do we conclude? It's neither. And I want to point out that's written over there. All right, let's go to the next one, and that's going to be B now. All right, so let's put B down. So B, I'm going to write this down for you. I'm going to write down f of minus x. And I'm looking at it. I'm going to look at the top. If I cube minus x, I get minus x cubed. That's not so bad. And minus x to the fourth power is just x to the fourth power minus 1. All right, so the big question becomes is f of x equal to f of minus x? Well, I'm looking at it, and the answer is no. So it's not even. I'll write that down for you. Not even. All right, let's go to the next one. I'm going to look at this now. Minus f of minus x. What's that going to give me? X cubed over x4 minus 1. So my question, oh, by the way, I should put a slash through that. Is f of x identical to minus f of minus x? We'll have to look. Let's take a look. And I want to point out what we're looking at. We're looking at this, and we're looking at this. Are they the same? And the answers are resounding yes. So what I'm going to conclude? I'm going to conclude that this thing is, sorry about that, that this thing is odd. Hold on one second. All right, what's the answer over there? It says odd. All right, this is good news. It's right over here. Let's go to the last one. Last one's pretty simple. It's a simpler one than the first two ones. And let's write it down. And what do you got? F of x equals x squared minus 9. Let me write that down for you. What's f of minus x? It's x squared minus 9. Whoops, got a little excited there. What's minus f of minus x? Well, let's take a look at it. It would be 9 minus x squared, right? Pretty simple. And the question becomes this: is f of x equal to f of minus x? And the answer is a resounding yes. It's the same thing. So what am I going to say? It's even. But I may be a little concerned about this, but I'm still going to look at the odd test. Is f of x equal to minus f of minus x? And the answer is it's not true. It's not the same thing. So it's certainly not odd. So what I say, it's even. I do want to point out these answers are given to you in the notes, and they're given to you for a good reason. We want you to look at them. And again, if you have questions on that, you should bring it to my attention. All right, during office hours, of course. Let's go to number 11 now. And number 11 is certainly, my indication over here is for a lot of students, what happens is they don't read. Give me 1 second. By not reading, you're hurting yourself. By the way, I'm guilty of it too. But anyway, I'm going to look at it, and it says, I'm given a graph. I definitely see the graph, by the way. And it says, I want to, point out that I've indicated some points on the graph, and I want to tell you what points I've indicated on the graph. And I've indicated this one over here. It's in blue, right? And what's that point over there? It's the point -2, 104. And I've indicated this point over here, and just looking at it, I'm going to say this point over here is 8 minus 396. All right, yeah, they've given me those points. And they've also given me the y-intercept, and I'll write this one over here, although not indicated, I'll indicate it now, is going to be 0.52. I want to point out there's other points we'd like to know, but they didn't give them to me. This point here, and this point here. And what are they? I'm going to say they're y-intercepts. And looking at those, I'm sorry, I misspoke, x-intercepts. I'm going to say, looking at this one over here, this thing, roughly speaking, looking at the picture, I'm going to say, roughly speaking, and when I say rough, I'm not saying it's right. I'm just saying, roughly speaking, this looks around 12 to me. I'm going to look at this one over here. And this roughly, when I mean rough, I mean rough. I'm not saying it's the right answer. It roughly looks like 1,0. And this one over here, roughly speaking, I don't know. I'm going to say maybe 4.5, 0. By the way, the picture could be deceptive, but I don't think it is deceptive. I think it's a pretty good picture. All right. So my question over here is, I'm looking at a picture. What are they going to ask me? All right. Let's take a look at the questions. The first thing is a domain. Well, that should be really simple because I'm looking at the function. And what's the function? It's x cubed minus 9x squared minus 48x. I'm looking at it right over here. And that's a polynomial. There's no divisions or even roots. So what's the domain of that thing? Well, it's really simple. It's just going to be minus infinity to infinity. What's the next question? what's the range? Well, I got to really emphasize this to you. The range is going to be, well, I'm looking at this curve, and this is a partial picture of the curve. Put this down for you. I'm tracing over my curve, by the way. And the reason I'm saying this is just a partial picture. And by that, what I mean is this thing goes on forever in that direction, goes on forever in that direction. And you know, certainly someone says, well, what is the range? It's what's being covered for the y's. And everything's being covered. All right, here comes the next thing. Where is it increasing? All right, I'm going to go through this with you. I'm going to say it's increasing as I move left to right if it's moving up. So here, it's increasing here. It's also increasing over here. Okay, now what is that? We put the intervals down moving left to right. What are the intervals moving left to right for increasing? Well, I'm going to say from minus infinity, I'm moving left to right, and it stopped moving up at -2. And then it started moving down. Union, where did it start moving up again? And again, we're moving left to right. We're talking about the axis. 8 to infinity. All right. What's the next question? Where is it decreasing? Well, I'm looking at the picture, and I'm going to say it's decreasing on this interval. What does it mean? As I move left to right, it's going down. All right. It's going down as we move left to right. Now, where's it going down? It's talking about the x's now, from -2 to the number 8. Right? What's the y-intercept? Well, again, if you can't remember, look at it. It's pretty simple. It's 0.52. That's pretty simple. The next thing is how many x-intercepts are there? Let's just talk about that. I'm going to look at it again. There's 1, 2, 3. So I'll write that down for you. There's 3 of them. And what are they? Well, I can't find the exact ones, and I'll tell you why. I can't factor that polynomial yet. I don't have the skill set for it. What you're learning Math 100, you couldn't have done that. So I could write them down for you. The approximate values, well, 4.5. I'm sorry, minus 4.5. Sorry about that. Minus 4.5, comma 0. The other one is going to be approximately 1, 0. And the other one's going to be approximately 12, comma 0. That's approximate. So we can only do approximate this page. Again, the reason for that is we really can't factor that polynomial. You can try though, but you're not going to get it. Symmetry, well, I'm looking at it. I don't see any symmetry, no symmetry. What symmetry are we looking for? Even and odd. I just don't see it. Is there a relative maximum? I want to point out, is there an open interval where there's a point bigger than another point? And there is. And what's that point? -2, 104. I'll write that down for you. Is there a relative minimum? In other words, is there an interval that contains a point smaller than other points? In an open interval, it certainly is. What's that point? 8 minus 396. All right, that's a point. All right, let's go to the next page. And again, I want to emphasize over the next page, you're going to see the answers listed for you. All right, the answer will be listed for you. And what I mean by that, you really should be looking at an answer key as you go through the problems. All right. Now, granted, I want to point out over here, they give much better approximations to the roots. And the reason for that is they're using a computer to do it. We'll do that later when I talk about SAGE. If for the students that want to do that now, SAGE is over here. You can actually type in the SAGE code if you like for that problem. All right. Don't feel like you have to do that though. SAGE is optional. You can also use your calculator to do that. If you have issues with your calculator and you can't use a calculator, but you have one and you need help with that, I would recommend coming by during office hours. All right. No symmetry, at least not the symmetry that we talk about. And we talk about these 2 points over here. So I'm going to go to number 12 now. And looking at number 12, you know, I realize that this one says, you know, given a function and its graph, answer each of the following questions. Well, you know what? The graph is on the next page. I'm just going to go through the graph of it, all right? Because it's like a Math 100 question. So typically I would write f of x as y equals, I'd factor it. It's factorable. And what do you get? X minus 3 quantity squared. Now I'm going to graph this guy down for you, all right? And what would I get over there? Well, an x-intercept of 3, 1, 2, 3, and a y-intercept of 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 over there. It's a parabola. The parabola looks like this. Now someone says, I don't remember ever doing that. That's something you did in Math 100. All right. You did parabolas in Math 100. Now someone says, well, the graph's on the next page. I like the graph on the next page better. It's a machine did it. Definitely a better picture. All right. So what do they want to know? A says domain. Well, I don't need a picture for that. And read it out. It's a polynomial, no division, no even roots. The domain is all real numbers. What's B? B is the range of it. I need a picture for that. And I'm looking at the picture. What do I mean by looking at the picture? I'm looking at this picture over here. The least it could be is 0. And then what's it do? It goes off to infinity. So I'll write that down for you. So the least it could be is 0. It actually touches that value and then goes off to infinity. All right. The intervals where it's increasing. Let me talk about this. All right. And this is the tough part for a lot of students. You're moving left to right. Where is it increasing? Here. This is where it's increasing. That's where it's increasing. So where is it increasing? Let's write this down. C, it's increasing from 3 to infinity. What's the next question? Is it ever decreasing? Well, you get the idea over here. Yes, it's decreasing from minus infinity up to 3. Again, look at the picture. As you move left to right, it's falling down here. It's actually falling down as you move left to right. All right, let's keep going. Let's go, that was D, by the way. Let's go to E. Ooh, y-intercept. Couldn't be easier. 0, 9. All right, let's go to the next one. And that was, oh yeah, the questions are over there. Oh no, wait a second, they aren't. This is F. What's F say? X-intercept, there's only one. Again, look at the picture. It's 3, 0. Let's go to G. Is there symmetry? No. However, in Math 100, they talked about what's called an axis of symmetry. Let me go back to the picture. The axis of symmetry is this line over here. By the way, but it doesn't have even odd symmetry. So axis symmetry, I want to write down, it's going to be X equals 3. But I'm going to say no symmetry that we're looking for, and that's even odd symmetry. So no even and no odd symmetry. All right. And relative maximum, well, looking at the picture, no, I can't find any open interval where there'll be a point bigger than all other points, but I can find H is none, but I can find what's called a relative minimum or local. And what's that going to be? Again, I want to point out to you, it's right over here. There's an open interval where this point is smaller than all other points. And what is that point? That point is going to be 3, 0, which is the vertex of the problem. All right. So let's keep going. And again, next page. They got the picture over there and they got the answers down there for you. Again, you may want to take a look at that. All right. As you study, you need to start taking a look at things and trying to make sense of those things. You can't just keep saying to yourself, gee, another thing I don't understand. Let me see if I can move forward anyway. You really can't. You need to study what we're giving you. Let's go to the next page. And next page is going to be more difficult. There's no doubt about it. It's a piecewise function. All right. So I'm going to just write it down for you. And I'm going to write down, there's two, looking at this thing over here, I'll point out what I'm looking at this over here. This is f of x, but it's given in pieces. And there's 2 pieces. The first piece is going to be x squared plus 1, which I definitely know is a parabola. So I'm going to write that down for you. So y equals x squared plus 1. Now, Math 100, what you did was you graphed that out, and that's a really easy parabola to graph. It looks sort of like this over here, right? The vertex would be here. And what's the vertex going to be? Well, looking at it, the vertex would just be 0, 1. It's a very simple parabola. Here's the problem, though. They say it's only going to be that curve if the x is below 1. So I have to get my eraser out now. And I got to start to erase this portion of the curve over here. All right? And I'm going to put a convention in. It says don't touch the 1. I'm going to put a circle on it. So what's that point over there? I'll write it down for you. This point over here is going to be 1. It's an open circle, by the way. And if you plug into 1 in the function, what would you get? 2. All right. Let me point out what we just graphed over here. We graphed this section of this curve. That's all we've done. There's an open circle over here. All right, let's do the next section of the curve. All right. And what's the next section of the curve? Y equals minus x squared minus 1. Well, if I were to graph that guy out, that would look like this. It's a downward facing parabola. And with the understanding the vertex is there. But here's what they said. They said the x is greater than or equal to 1. So I got some erasures to make over here. And I'm going to go through that with you now. So the erasures, it can't be this thing over here, can't be that. And then it's going over here. And it's going to start up at 1 again. I get my pen out. I'll put a little circle over here. It can touch it, and our convention for touching is shading it in, just like when we did inequality. And what's that point over there? It's going to be 1, because it can touch the 1. And if you plug in 1, what would you get? Well, minus 1 is minus 2. Yes, you expect to do simple arithmetic. Let's trace that in for you. And I'll put a dot over there. I'm going to put the points down in the picture. What's this point over here? 1, 2. What's this point over here? Well, that's going to be 1, minus 2. And this point over here is a vertex. And that point's going to be 0, 1. All right. Again, someone says, what's the interval? I'm sorry, what's the domain of the problem? And I really think I can do it. Right? I really think I can do it. All right. So when I'm doing something, I hope you realize that I'm looking at the picture now, but I'm also looking at the function. And what's the domain of that? Well, I want to point out what we're looking at. We're looking at this thing over here, and this covers all the numbers. So the domain of it's all real numbers. What's the range of it? More difficult. I know that. But range is, what's the y being covered? Well, it's certainly going towards minus infinity, and then it goes up, and it's going to hit this thing over here, and that's the value minus 2. But then there's a big missing space over here. When does it connect again? Well, at the value 1. That's the value there, and then it goes off to infinity. Let me write that down for you. Minus infinity, it streams all the way up to minus 2. It touches it. Union starts up at 1 again, touches it, and goes off to infinity. These answers are in your notes. All right, let's do the increasing, decreasing part. Give me 1 second. Let's see. Intervals where f is increasing. I want to point out what I mean by that. There's only one spot I see it increasing, right over here. Let's write that down for you. It's increasing from 0 up to 1. Where's it decreasing? Let me go through that with you. Here, moving left to right is going down, and here, moving left to right is going down. Let's write that down for you. So it's going to be from minus infinity up to 0, union 1 to infinity. Students struggle with this. You want to struggle. You want to struggle, but you want to learn. What's the y-intercept? It's a point. What's the point going to be? 0, 1. How many x-intercepts are? There's none. Is there symmetry? There's none. I don't see any even or odd symmetry. Let's go to the next page. And, oh, relative maximum, relative minimum. Sorry about that. And relative maximum, I don't see anyone. There's no point on an open interval that's bigger than all other points, but there is a relative minimum. So no relative max, but there is a relative minimum. And where is that point? Well, I'm looking at it. It's the vertex of that parabola. And what's that point going to be? 0, 1. All right, let's go to the next page. And next page, we're looking at, kind of simple questions. And I'll tell you what I mean by simple questions. They're asking if these things are functional. And let me just make sure you know what that means. So, you get 2x plus 3x equals 7 is a function. There's several ways of doing it. One, you could graph it out. So if you graph this out, I'm going to point out it's just simply a line. That's all it is. A line with negative slope. That's all that is. That certainly passes the vertical line test. So it's definitely functional. The other thing I'm going to point out at this level of the game, if you can solve for y. Let me see if I can do that. 2x plus 3y is equal to 7. 3y is equal to 7 minus 2x. Y equals 7/3 minus 2/3 of an x. So I'm going to say it's functional. Now, if someone says, why do you know it's functional? You could graph it. It's a line, and it certainly passes the vertical line test. Or you could solve for y in this class. And if you could solve for y, you got a function. All right, let's go to the next one. And I want to point out, some people say, I struggle with this. We're not asking you not to struggle with it. We want you to learn the material. All right, but I'll write this down for you. And what's this going to be? Y squared minus x equals 5. Let me see if I can solve for y. Y squared equals 5 plus x. And y equals, unfortunately, it's two different things. It could be root of 5 plus x, or it could be the opposite of the root 5 plus x. So there's two different problems there. So this is not functional. Okay, if you were to graph this guy out, and I'm not opposed to that, your graph would look like this over here. This certainly fails that vertical line test. It hits it twice. And this is what's indicating it over here. It would hit it twice. There's a plus side of it and a minus side of it. All right, let's go to 16. 16 is a little bit, it's a strange question to me, but it's not a bad question. And it goes on and says, A is a set of people in a classroom, and let's say just our classroom, and B are the numbers between 0 and 10 measured in feet. Well, I'm going to say everyone in the classroom has some number associated to them in feet. Everyone does. This is A, and this is B, and there's people in the classroom. But everyone in the classroom has a number associated with them. Everyone does. And what number? Their height, right? Everyone's got a height. So the question goes, says, is the reciprocal functional? Of course it is. Everybody's got a height, all right? Everybody's got a height. What's the range of it? Well, the range might be more difficult to get. You'd have to ask everybody's height, all right? So for example, if I did this, some people might be 5.1 feet, other people might be 4.9 feet, some people might be 6.3 feet, other people might be 5.7 feet, yada, yada, yada. I'd have to ask around. But again, it's functional with the range, everyone's height in the classroom in that given day. All right, let's go to the next question, and which is number 17 and 18. Let's take a look at it. It should be simple. 17. What's 17? Evaluate the function. Oh, good. This should be easy. Let me blow that thing up for you. So A, f of minus 2. Here's the deal. Look at the function. It's given in pieces. Which piece would allow you to touch minus 2? This first piece, because minus 2 is below 0. So let's write that down. So what do you get? 4 times minus 2 plus 5, which would be minus 8 plus 5, which is minus 3. That's given. Let's go to B. F of 0. Well, again, which one of these two pieces would allow me to touch 0? It's still the first one. So what do I get? 4 times 0 plus 5, which is 5. That's over there. What's f of 2? That's C. I'll put it down for you. Well, which one of these two would allow you to touch the number 2? And let me just point that out to you. It's this one. So it's going to be 4x squared plus 4. And that's going to be what? Well, 2 squared is 4. 4 plus 4 is 16. 16 plus 4 is 20. Okay, let's keep going. This is number 18. They're getting a little bit easier for me. And what's 18? Oh, when does f of x equal 0? Well, let's write down. When does 2x minus 10 over 9 equal 0? Well, that couldn't be any easier. Solve the equation. You get 2x minus 10 equals 0. 2x equals 10, or x equals 5. Again, the answers are given to you. Thank you.